Hello everyone. These are going to be the notes on similarity, and I would say this is the first set of notes in this class that are a bit difficult. They're going to be a little bit different than what you're used to, and it's going to be a lot of information. So if you need to watch this over and over, that's fine. If you need to ask me questions about it, please do. But hopefully this video helps you to figure out what similar polygons are. So in the last test, we talked about congruent polygons, where they were exactly the same size and the same shape. Similar polygons are two polygons with the same shape but different sizes. Now when I say same shape, I don't just mean they're both triangles or they're both squares or they're both rectangles. I mean they have the exact same shape. So they have the identical shape to each other. So if they are two triangles, they still have to hold the same shape. So what that means is these two polygons down here are similar. They have the same shape. So if they have the same shape, that means that their angles are going to be equal. So the angles are still equal in similar polygons. So if this one over here is a right angle, then that means that this one's going to be a right angle. And no matter what A is, W will be the same. And D will be the same as Z, and Y will be the same as C. So angles are still equal. That's what keeps the shape the same, because it keeps the polygon in the same shape. But what happens now with the sides is that the sides are going to be proportional. And you were doing proportions in your last section. So proportional just means that they have the same ratio. So for example, let's say that this side, the length of this side is 6. If the bigger figure is twice as big, that means this side is going to be 12. If this side over here is 3, then that means this one would be 6. If the side down here, if these two were both 5, then that means that these would be both 10. Okay, so if it's double, then that means all the sides are doubled. But the angles, again, are still the same. The angles are equal. That's what keeps the shape the same. Now, proportional, that means if I take any proportion from this figure and this figure, they're going to be equal to each other. What I mean by that is, let's say I make a proportion here of 10 over 12. So we're doing the left side to the top. If I look at this one, left side to the top, that would be 5 over 6. Now if I were to cross multiply, I would get 60 equals 60. So all of them are going to be proportional. I could use any two sides to equal any two sides of the other figure, and those proportions are always going to be equal. So this information right here is going to help us solve our problems. For all of these problems today, well, most of them, we're going to use proportions. We're going to be setting up proportions to solve. And down here, I don't want you to miss this. That right there, that's the symbol for similarity. So if you remember, congruent had an equal sign with a little squiggly above it. Now similar is just the squiggly. So that just means that those two are similar to each other. So I know there's a lot of information, but it tells us here that figure 1 is similar to figure 2. So I know that they're similar. So right off the bat, I know that if L is 22, that means R is also 22 degrees. Okay, because angles are equal. Now they didn't give us any other angles in the figures, so I can't match them up, but I can match up the 22s. Now, they want us to find side LH. So here's side LH right here, and I'm just going to name that X, just to give it a variable. Okay, now to solve for that, I need to set up a proportion. So x in this figure matches up with 24 in this figure. They're both on the bottom. So that's going to be my first fraction, x over 24. Now my second fraction, I have to find another pair of sides that go together. And if I look, I could use 25, this is the left side, and 20 on the left side. I could use that fraction if I want. Or I could use 15 is on the right side, and 12 is on the right side. I could use that fraction if I want. I cannot use 20 up here because I don't know the top over here. There's no value there. So I have to either use 25 over 20 or 15 over 12. I'm going to use 25 over 20. Now make sure the 25 is on top, just like x is on top. I went from figure 1 over here with x to figure 2 over here with 24, so I have to do the same thing with this fraction. So the 25 has to go on top, and the 20 has to go on the bottom. And now I'm going to cross multiply just like we did in your notes from the last section. So if I cross multiply, I have 20 times x, 24 times 25, sorry about that. 24 times 25 is 600. So when I divide by 20, I get that x is 30. Okay, so x over here is going to be 30 centimeters. So that's going to be our side LH is 30 centimeters. Okay. What's the measure of angle R? We already figured that out. That was 22 degrees. And now we need the length of side ST. So, side ST is over here. And instead of using X this time, I'm going to use Y. You could use X again if you wanted, but I just wanted to keep it different so we don't get confused. But I'm also doing it in the different colors so you can see it. Okay, but I need to set up a proportion again. So, Y here goes with 20 up here. They're both on top, so that'll be my first fraction. And then my second fraction, I can use any of the three pairs because I now know that this side is 30. So I could use 20 over 25 again, I could use 24 over 30, or I could use 12 over 15. This time I'll use a different one. I'll use 12 over 15. And again, make sure that you're lining up these properly. Y comes from this figure, and that's on top. So 12 comes from this figure with the y, so that also needs to be on top. So y over 20 equals 12 over 15, and now we'll cross multiply. So 15y is 240. Divide both sides by 15. And y equals 16. So this side will be 16 centimeters. And now perimeters. We know how to find perimeters. We're just going to add up all the sides. And when you do that, you get that the perimeter of figure 1 is 90 centimeters. And the perimeter of figure 2 is 72 centimeters. All right. For this next one, okay, before we even start looking at the questions or anything, I'm going to fill in my angles. I always like to have the angles on the sides all filled in. It kind of helps a little bit. So the first thing I'll do is subtract 55 and 76 from 180, because we know all three angles in a triangle equal 180. And that equals 49 degrees. Now, these triangles are turned on their sides. They're not in the same orientation. So I'm going to have to use my similarity statement up here to line things up. So just like with congruence, A goes with D. So if A is 55, D is 55 degrees. B goes with E. So if B is 76, E is 76. And then C goes with F. So if C is 49, F is 49. And now they ask, what's the measure of angle E? Well, the measure of angle E is 76 degrees. Now, the next one tells me if the smaller triangle is a third of the size of the bigger triangle, find the three sides of triangle ABC. Okay? So it's a third of the size. You can set up proportions here if you want to, but I think the easier thing is to say, well, if the smaller one is a third as big, that means this is 3 times as big. So I'm just going to multiply all these sides by 3 to get the sides of ABC. Now again, I need to line them up. So DE goes with AB, so that's down here. So 3 times 3 tells me that this side is going to be 9 millimeters. DF goes along with AC. So 3.5 times 3 is 10.5. So this over here will be 10.5. And then finally EF goes with CB. So 2.5 times 3 is 7.5. So that goes here. Okay, so we found the three sides of triangle ABC. 1, 2, 3. And then the perimeter of ABC, we would just add them all up, and you get 27 millimeters. Now I do want to tell you that the perimeters are also in proportion to each other. Just like the sides are in proportion, the perimeters are in proportion. So if you wanted to, you could have also added the three sides of the little triangle, 3 plus 2.5 plus 3.5, and then multiplied that by 3, and you would still get 27. So 3 plus 3.5 plus 2.5, that's the perimeter of the smaller triangle, DEF. So if I take that times 3, I get 27. So I just wanted to let you know that the perimeters are also in proportion to each other, just like all the sides are. Alright. So again, we have two that are not in the same orientation. We can see one has been turned on its side. Okay, but if I match them all up, here are my two right angles. This M and H are the same, so this is 25 degrees. And E and J are the same, so this is going to be 65 degrees. Okay, so I need to find the values of X, Y, and Z. Well, I already have Z. Z is 65. So now let's find X. So X is here, side KL. Okay, so I'm going to set up a proportion. So X over 11, and the reason why I chose 11 is because KL goes with FG, and now I can pick any two sides that go together. I don't know what this side is, so I'm not going to use that. This side, 30, goes with Y, so I can't use that, so I have to use 20 and 8, JK and EF. So X over 11 equals 20 over 8. I will cross multiply. 8x equals 220. Divide both sides by 8. And x is going to be 27.5. And now I'll do the same for y. So y is here. Y goes along with 30. Oops. Y goes with 30, so that's my first fraction. And now I'm going to use 8 and 20 again, only now 8 has to be in the numerator, and 20 has to be in the denominator, because 8 goes with the y and 20 goes with the 30. So now again, I'll cross multiply. So 20y equals 240. So when I divide by 20, y is 12. And then finding the perimeter of both polygons, again, that you're just adding up the sides, so that's going to be 34 for the smaller and 85 for the bigger. Okay, the last two deal with drawing your own triangle. So it tells us that ABC is 2.5 times bigger than the triangle shown here. So we want to draw that, and we're going to label each angle and each side. So here's triangle ABC. Remember, angles are equal. So this is still going to be 60, 60, 60. And all three sides are still going to be the same. Just to figure out what they'll be, I'm just going to take 12 times 2.5. 12 times 2.5 is 30. So that just means each side is going to be 30 yards. And that's it. So just remember, the angles stay the same, and then whatever the proportion is that they tell you, you just multiply the sides by that. In this case, they're all going to be the same still. Okay, last one. So triangle ABC is 3 times smaller than the triangle shown here. So we're still going to draw it, and it doesn't matter where you put A, B, and C. Okay, remember, your angles stay the same. So that's still 90, this is still 37, this is still 53. Now, it's 3 times smaller, so I'm going to divide all of these by 3. So my left side is going to be 4 feet, my hypotenuse here is going to be 5 feet, and the bottom is going to be 3 feet. And there it is. So just remember, for all of these problems, you're going to be setting up proportions for a lot of them. Make sure that you line the things up correctly. Your angles are still going to stay the same. Okay, if you have any questions, feel free to watch this again, or you can ask me.